Welcome to this advanced shell scripting video titled How to Use the Shell Script Template written by me, Dana French. Additionally, this video contains step-by-step instructions for creating and using shell script function libraries. The shell script template presented in this video provides a shortcut to writing complex shell scripts and encourages standardization of shell script coding. This is not for the beginner. Advanced topics are discussed in this video. Some of the shell scripting features presented in this video and utilized by the template include functions, both Corn Shell and POSIX functions, how to trap and process signals within your shell script, the GetOps function, which is used for processing CommandLine options and arguments, the concept of automated documentation and generating your documentation from the shell script itself, automated and dynamic reconfiguration of your shell script while it is running, usage messages, which allow the user to display help messages and syntax messages about how to run your shell script, and debugging and verbosity levels, which can be built into your shell scripts. This template demonstrates best practices for creating, documenting, coding, and utilizing shell scripts and shell script function libraries. So to get started, let's first go get the shell script template that can be obtained from Mt Xia. So go to mtxia.com, that's mtxia.com, and you'll want to go to download and scripts, and from there you'll click on Corn for Corn Shell scripts, and then we'll scroll down in this page until we see the menu item for shell script template _ K93. You'll want to click on the non-HTML version, and that's because the regular version contains HTML coding, so click on the non-HTML link, and that will display the text file that contains that shell script without any HTML coding. So we'll want to copy that file, so I'm going to do a Control A to mark everything, and then I'm going to do a Control C to copy it, and then I'm going to come to my local system, and I'm going to open a file called display.msg.kshell, and I'm going to paste the contents of that copy into this file. Okay, and so I pasted the contents. I'm going to go back up to the top of the file, and I'm going to write the contents. Now then, be aware that this template is written so it's compatible with a wide variety of shells, including Corn Shell 93, regular Corn Shell 88, or Bash. So you don't have to run this template as Corn Shell 93. You can run it in any of those shells. It is also written using functions so that the resulting shell script can be easily executed as a standalone shell script, or incorporated into other larger shell scripts, or included in a function library. The template contains 3 pre-written functions, and the first function is at the top of the template and is the usage message. The second function is a configuration function, which allows you to dynamically reconfigure the script while it's running. And then the third function is the body of the shell script. And the third function is where you will want to modify the function to add your commands. And so we're going to edit both the usage message and the body of the shell script. Now notice that at the top of this script is a shebang line, and it is currently set to Corn Shell 93. You can change that to Corn Shell or Bash, or whichever you prefer. I prefer Corn Shell 93, so I'm going to leave it as is. The next thing to notice in the template is the function line. Notice this function is the usage message _ your _ function. This is a usage message that is displayed if incorrect command line options or arguments are entered when running the shell script, or if the user simply requests syntax help on how to use the script. You should change this usage message to reflect the features and functions of your shell script as you modify the template. So the first thing you'll want to do is change the description. You want to try and keep it short but descriptive. And so for the purpose of this video, I am going to change this message to be: this function displays the default phrase, and I'm going to suppress the special meaning of the double quote, and I'll explain that in a moment. Hello world, and again suppress the special meaning of the double quote. Or it displays a message provided by the user on the command line. Okay, so I'm going to get rid of that and save it. So now the reason I use the suppress the special meaning of the double quote here and here is because I'm simply printing all of this as a single print command. So I've got everything contained within double quotes here and here. So if I use double quotes within those two, I have to suppress the special meaning so that they are seen as literal double quotes. So now then, next we will add the command line options to our usage message that you plan on using in your shell script. If you don't know what they are yet, then you'll come back to this later and add them as you write them into your shell script. That is usually the way it works for me. I don't always know what command line options I want until after I begin writing the script. So for the purpose of this video, we're going to add an option to the usage message to accept the command line argument from the user. Now this option will specify a message to be displayed by the script. So the first thing I'm going to do is I'm going to add the option, the syntax of this, to the usage line in my usage message function. So I'm going to say that I want to have a -m as my command line option, followed by some message to be displayed on the screen. Now then, I typically use man page type syntax to indicate which options are required and which are optional. Those that are in square brackets are considered optional commands, and so that's what I'm trying to indicate here, is that this is an optional command to my script. So next I'm going to add a description of my option that I added. So I'm going to say -m message is equal to change the message to display. And I'm also going to say that that message has to be 3 characters or longer. I'm going to make that a requirement. Doesn't have to be, but I want to do that simply to illustrate trapping trapping option errors. And so I'm going to make this be 3 characters long so we can test that later on in the script. Now some of the other options that you're probably going to always want are included in the template, such as a verbose option. You can toggle verbose mode on and off using a -v option, and we'll see how to do that later on in our template. -V, which is very verbose mode, and again we'll see that later on, and a -, which tells it to display this message. So anytime somebody runs your script with a -, command line option, it will display this usage message to tell them how to use your script. Then finally, you can end the message with author information if you want. You don't have to include that, but I typically do. So there it is. There's your usage message function. Now then, the next section of the template is used for documentation of the shell script, and notice that each line begins with 4 hash marks and a space. The 4 hash marks are used to identify the documentation lines and within that script, and this syntax is used to identify what lines you want to be extracted by an automated documentation system in order to automatically generate documentation from the script itself. So rather than having to maintain the script and another documentation file, you can use a documentation generator to extract your documentation straight from the script. The automated documentation generator is itself a shell script and is called AutoDoc, and we will describe that in another video. That is, the description of automated documentation is outside the scope of this video. So for the purpose of this video, just know that you can automatically generate documentation using the syntax shown, beginning the documentation with 4 hash marks followed by a space, and then anything after that is considered a documentation line. So the documentation section of the template provides the following headings. You have a description heading where you place a full text description of your shell function. Assumptions, so any assumptions that your script makes need to be listed and provided here so that anybody trying to run or modify the script knows what those assumptions are. Dependencies, again, if your script has dependencies, they need to be listed here. Products, whatever your script produces, you'll want to give a list of those here, the different types of things that your script may produce. And then maybe some examples of configured usage, how you would use the script. And then the details are actually the code, the script code. So you don't need to place anything after details. That just simply indicates the script is forthcoming after this line. The next section of the template provides a configuration function that is used to configure or reconfigure the shell script while it is running. So configuration variables can be stored in a file, typically a file indicated by the C file variable within this function, and then those variables within that file are sourced using a dot script, and the way we can tell it to execute that is by using a trap within our script. Whenever our script receives a hang-up signal, we can tell it to trap that signal, and upon trapping a hang-up signal, to reconfigure the script by re-executing the configuration file identified in the C file variable as a dot script, and we'll see how to do that later on in our shell script. So now we get to the body of the shell script. This next section, this next function, will become the body of our shell script. And we can see that it is programmed as a function, and it has a name right now called your function. I'm going to change this name from your function to display message. Remember, when I opened this file, I gave it a name of display message.ksh. Well, I'm going to change all occurrences of your function to match this file name. So I'm going to go to the top, and I'm going to replace your function with display message. So now you can see that my usage message underscore your function changed to underscore display message. So I've changed all occurrences of your function to display message. So let's get back down to where we were, and we see here's the body of our shell script, and its name is now display message. So within our display message functions, there are several variables defined at the top of the function, and we see that those variables are called version. There's a version variable, true, false, verbose, and very verbose. And we see that version has a value of 1.0, and this allows you to keep track of the versions of your shell script as you modify the script. We have a value for true and false. Here we're setting true equals 1, false equals to 0. And using those values, we're setting a couple of toggle switches called verbose and very verbose, and we're initializing those as false. We'll see how to use those toggle switches of verbose and very verbose and true and false later on in the script. Now, it's important to note that using the typeset command within a corn shell function will cause this variable to become local to the function. So within a corn shell function as defined here, anything that is defined using the typeset command, any variable that is defined using the typeset command, will be a local variable to this function. So now let's talk about dynamic reconfiguration of our shell script. Configuration variables can be defined in a configuration file and then initialized using a signal. And by default or normally, the hang-up signal is used to indicate a reconfiguration signal. And so we can send our script a hang-up signal to tell it to go run some function, and in this instance we're going to tell it to run the configure display message function whenever that signal is received. So what does that mean? Well, we need to define within that configure display message function, remember we defined a configuration file called display message.conf. So let's go edit that file and add a variable, let's define a variable in that file. So I'm going to exit this script first. And now then, we know that my display message file is in my home directory called display message.config, and it starts with a dot, so it's going to be a hidden file. So within that file we're going to define a variable called message, and we're going to call it hello world. So we see we've got that in there, and we'll save that file and exit from our editor. So now we have our display message config file defined, and we'll use that later on in our shell script. So let's go back into our shell script and go back to where we were within the script. So we saw that we could trap a hang-up signal to cause it to run the configure display message. Well, now let's tell it to run that configure display message script. And the way we do that is we tell the script to send itself a hang-up signal. And we can do that with the kill command. So we can say kill and use the hang-up signal -HUP and send it to $. $$ is the process ID of the current process. So this script will send itself a hang-up signal that causes it to run the configure display message script, which causes that to then execute that configuration file defining the message variable. So now we could turn off this trap right here, but what we want to do is to leave that trap running for the hang-up signal, so that while our script is running, anytime it receives a hang-up signal while it's running, it will re-execute the configuration of itself. And so we can actually dynamically change the configuration of our shell script while the script is running simply by sending our script a hang-up signal. So next in the template is the GetOps function. And what this does is it processes command line options and arguments. Each acceptable command line option is identified in the op string, and this is the op string. And it consists of a string of letters followed by either a colon or a hash mark. Now, a command line option followed by a colon indicates that an argument is expected to be following that option. An argument can be any character, string of characters, or numbers. A command line option followed by a hash mark indicates that the following argument is expected and that the argument is expected to be a number. So in the template, the op string is defined by default as a colon, lowercase v, uppercase v. So op string, the leading colon in op string tells the GetOps function to fill the option argument with a colon if it receives an invalid option on the command line. So if you tell it a wrong value, it's going to get a colon as the option. The lowercase v is used to toggle the verbose variable to a value of true. Remember, we initialized it to false. Well, this will then tell it to toggle that as true. Same with the minus capital V. If we give it a minus capital V on the command line, then it's going to toggle the very verb variable to a value of true. And again, we initialize that to false when we define that variable. So if you remember, when we defined our usage message, we gave it a -m option. We told it we wanted a -m option. So I'm going to add that to our GetOps op string. So I'm going to add m colon, which means that a -m on the command line is a valid option, and that if a -m is specified, a command line argument is expected following the m. So now I'm going to add a -m value to the case statement so that if a -m is specified on the command line, that it will be recognized and do something within my case statement. So what I'm going to have it do is to set a variable called message. Remember, we used message in our configuration file. So I'm going to change that default message value to opt_arg, which is the argument following the -m on the command line. Remember, here we said m colon, so this says if you see a -m on the command line, an argument following that option is expected. What I'm doing here is saying if you see that -m, then set the variable msg, message, to whatever this argument was following the -m, the option argument. So understand what we just did here. Within our configuration file, we told it that msg was equal to hello world, and now we're telling it that if you specify a -m on the command line, you can change that value to whatever you want it to be on the command line, and it will assign the msg variable to that value. When all of the command line arguments are processed, all of the command line options are processed, the while loop exits, and the index number of the positional parameters is set to the positional number of the next command line argument in the list. This index number is set to the variable opt_end, opt_ind. So this variable will contain the next command line argument to be processed. Now at this point, all of the command line options and their arguments have been processed by the GetOps command and can be removed from the command line because they're no longer needed. So we're just going to clean up the command line now. Now, however, additional command line arguments may still exist that were not associated with command line options. So there can still be command line arguments out there. So what we're going to do is remove the options and arguments that have been processed by the GetOps command, and we're going to use the shift command to do that. We're going to shift off all of the command line arguments and options that have been processed. So since opt-end is set to the index number of the next unprocessed command line argument, we're going to subtract one from that, and then we're going to shift off all of the processed options and arguments using this command. Now in our example there will not be any additional arguments, but it is always a good idea to clean up your command line as you run through your script, so that everything is set correctly, so that in the event that you make future modifications to your script is doing things correctly, and you don't have to worry about whether things got cleaned up correctly. So you did it correctly here. So everything's ready to process further command line arguments should that happen in future revisions of your script. So now that we have identified and processed all of our command line options and arguments, we want to test them to make sure they have valid values, make sure they make sense. So what we're going to do is, between the trap commands here, we're going to trap the exit, and what we're going to do between those two traps is to test our command line arguments. Now our only command line argument was the -m, and if you remember, let's go back and look at our usage message. We said that the message had to be 3 characters or longer. So if the message is not 3 characters or longer, then we want to trap that and display a syntax message. So what we're going to do is we're going to say we're going to test our length of that message and see if it's 3 characters or longer, and if it's not, we're going to return from this script with a non-zero return code. So let's see what this says. We're going to test the length of the variable MSG now, and if it's less than 3, then we're going to return from the function with a value of 2. And so once we have processed all our option tests, then we can turn that trap off. So here we turn the trap on for exit. If this test fails, or if this test is successful, then it's going to exit from the function, which will cause it to trap that exit here and display the usage message function. And then we'll turn that trap off. We'll turn the exit trap off on this command line. So now let's look at our toggles, our very verbose toggle and our verbose toggle that we set. If the user wishes to run the script in debug mode, they can specify the -V option on the command line. If -V is specified, then the value of variable would be toggled to true, which will cause the set -x command to be executed, and this will cause the remaining commands in the script to be executed in debug mode, which will display the intermediate step of every command before it runs each command. So if the user wishes to run the script in verbose mode, they can specify the -v, and that will toggle the verbose variable from false to true. So what that does is it allows the script programmer to use the verbose variable within the script to display information or execute commands whenever the -v command line option is specified. I will use the verbose variable later in our script, and we can see here that it's used to display the version number. It's used to display the version variable that we defined in a typeset command at the top of our script, at the top of our function. So now the next section of the script is going to contain the body of what we want this script to do. And in this example, I'm going to use the message, the MSG variable that we defined in our configuration file and that we defined above in our GetOps case statement. And we're going to display its value on the screen. So we are also going to use the verbose variable to display information about the MSG variable before we display it. So what we're going to do is I'm going to remove what is here now, and I'm going to add some information. So I'm going to say if verbose equals true, then I'm going to print content of MSG like that. So now then, if the user had specified the minus lowercase v, that would have toggled the verbose variable to true. So if that test is true, then it's going to print this message, which will print the content of the message and its value. So also what I think I want to do is to, if the verbose flag is true, then I'm going to also tell what the length of that message is. So in order to get the length, I'll put a pound sign in front of my variable name. And then now let's also print the message that was defined. And again, we're getting this value. We're getting the value of MSG from either our configuration file or from the command line. Now remember that at the top of this function we defined a trap for the hang-up signal, and we told it that if you got a hang-up signal to rerun or dynamically reconfigure the script using the configuration file. Well, here we're turning this trap signal off before we return from the script, and then here we return from the script with a 0 exit code. And that's the end of this script. That's the end of this function. Now, that's not the end of the file, however. We see that at the end of the file, we have a display message command with this syntax out here, double quote, $@, double quote. What this says to do is to pass all command line arguments, each argument double quoted, to the display message function. So the display message function is the body of our function. So this is the display message function. That's what we want to run. So as a standalone file, building functions into this standalone file, we have to run the primary function at the end of our standalone script. So that's what that's doing here, is running the function, the primary function, at the end of the script after all the functions were defined. So the advantage of doing it this way is that since the display message function is written as a function, it could also be included as a function in another script, or it could be referenced from a shell script function library, or it can be run as a standalone script as we're doing here. It is recommended that you write all of your scripts as functions. This gives you the flexibility to utilize your scripts in a wide variety of applications without having to modify the scripts every time you want to use that function or use that script in a different scenario. So write all your scripts as functions, and then you can use them in a wide array of applications. So now we can save the changes we made to the shell script and try to run this new script. So let's look at it first. and we see that it's not executable. So let's do a chmod 755 on this script, and we see that it is now executable. So now remember, we initialized the MSG variable in a configuration file, and that configuration file was under my home directory /display message.config. Remember that file? So let's look at the contents of it. So it contains the message equals hello world. So let's just run this script now that we just created. Let's run display message without any options or arguments. Just run it and see what happens. So we see what it did is it caused itself to generate a hang-up signal. It went out, read the configuration file. The configuration file had defined in it a variable called MSG and set it to hello world. And then it displayed hello world in our function display message. So now then, let's run this script again, and let's give it a command line argument. Remember -m that we defined? So let's give it a -m, and the argument to the -m is, we'll say this is a test. So what should happen now is it should overwrite, it should obtain this argument from the command line and overwrite our default message of hello world. And that's what we see. So now it's displaying this is a test. So now let's try something else. Remember, we set a length test. We told it had to be 3 characters long, the message that we wanted it to display. Well, let's try running it now with just a string that is just 1 character long. We'll do the -m option with just an A as our message to display. Well, what we got back now is the usage message. Remember, we trapped the errors. We did a test on our message that we provided on the command line to see if it was at least 3 characters long. If it was not 3 characters long, then we told it to display the usage message. So let's go look at that. Let's go look at that code. So remember, here we set a trap for and told it on an exit display the usage message. Here we tested our message, the length of our message, to see if it was greater than 3 characters. If it was not greater than 3 characters, return from this function. Well, that return was trapped here, caused it to display the error message, and so that's what we saw. So let's do that again. So -m A, we get the usage message. Well, let's try with 2 characters, AB. Well, again, we get the usage message. It wasn't great 3 characters or more. So let's try ABC now. And so now we see it displays ABC because the message is now 3 characters long. Now let's run the script using the -v option, the verbose command line option, and see what it does. So now we see the messages defined, the messages that we defined when the verbose variable is used, when the verbose option is used on the command line. We see those messages that we defined within our function. So when verbose variable is true, at the end of the output we see that version message we told it to display if verbose was true. We see the content of the message variable that we told it to display if verbose message was true, and the length of the message if the verbose message was true. And then we see the print at the end of that. So now let's run it again, but this time use the -V option, or the very verbose command line option. Now, if you remember what that does, it sets the debug mode on. So now what it's going to do is display every command as it runs the command and show us the intermediate steps as those commands are running. Notice that it did not display the verbose messages, it just did the test for verbose, and that's because the verbose flag is still false, because we told it to do very verbose, not verbose. So the verbose toggle is off, or it's false, so we didn't get any of those messages, but we did get the hello world, and we see all the commands that it's running as it's processing each command. So now let's run it with both the very verbose and the verbose flag on, minus capital V and V. And so what we see now is that it is displaying the debug mode is on, and the verbose flag is true, because we're getting the print messages associated with the verbose flag. So now, since verbose was true, we got this print of the version number, we got the print of the content, and we got the print of the length. And we also get hello world at the end. So we can see all the commands as they're running, and we can see all of the intermediate steps of each command as it runs. So we see that the standalone script can be executed from the command line with all of the functions contained within a single file. Now let's see how we can create a shell script function library and reference each function as it is needed from an external shell script. Shell script function library is simply a directory that contains shell functions, each function in a separate file, and each file with a file name that matches the function name. So the first step in creating a function library is to create a directory to contain the functions. This directory can exist anywhere, can have any name. For example, each user can have their own function library. But if the functions are to be shared between multiple users, a centralized location may be desirable, such as user local functions. For the purpose of this video, I'll create a directory for the function library under my home directory, and I will name the directory functions. So what I'm going to do is do a make dir in my home directory and call it functions. And then let's take a look at that. And we can see that it exists out there. So the permissions on that need to be 755, so it's already 755, but I'll go ahead and go through the motions of setting that. We'll say dot function. Remember, I started that with a dot, so it is a hidden file. It is a hidden directory. And so now then let's look at that again. Dot functions. Okay, so it's out there, and it is ready to accept shell script functions. So now I'll create the functions in the function library. To do this, I'll first copy the shell script file that we previously created, the display message.ksh file, to the function library directory. And I'm going to copy the display message file into 3 different files in the function library. So I'm going to copy it once for each function contained in the file. So I'm going to do a copy display message to my home directory /.functions, and I'm going to copy that to a file name of usage message display message. And so that, remember, that was one of our function names. And so now then I will copy that to configure. Remember, that was another of our function names. And I'll also copy that to simply display message. That was our 3rd function names. And so now I'm going to edit each one of these files and remove everything. I'm going to go into my function directory. And I'm going to remove everything from each of these files that is not associated with each individual function. So This will make more sense when I'm doing it. So this is the configure display message file. So I'm going to remove everything from this file that is not associated with that function. So I'm going to remove all of that and then come down to the bottom of it and remove everything following it. So now the only thing in the configure display message file is the function configure display message. And so I'm going to do the same thing now for the display message function. And remove everything that is not within that function. So now the only thing in this file is the function display message. Remember, and see that I removed that command at the end that ran the function. So the only thing in here is the function itself. And then finally, I am going to remove everything from the usage message display message file that is not associated with that function. So now then the only thing in this file is just that function, the usage message function. So now we see that I've got 3 functions out here, and the contents of each function is simply the function itself that is the same name as the file name. So each file should have the exact same file name, and each file should start with the function name. So let's look at that again. So the configure display message file contains the function configure display message, and it begins at the top of that file. Same with the function display message, and the same with the function usage display message. Now those functions that begin with the word function are corn shell functions, and those can have local variables. A function that does not begin with the word function, as this syntax shows, is a POSIX function, and it does not contain global variables. So now we've created our functions in our function library. So now what I'm going to do is go up one directory, and I'm going to create a new shell script that will utilize the functions in our new function library. So I'm going to create a file called temp.sh, and in that file I'm going to use a shebang line, and I'm going to use corn shell 93, and in here I'm going to give it a path. I'm going to define an fpath variable. I'll say fpath equals, and I'm going to tell it my fpath equals /.functions. Now the fpath variable is used just like a normal path variable, so you can specify multiple function libraries, each library separated by a colon. In this example we only have the one function library, so that's all I'm going to specify. And the function display message is then going to be called from that function library. So I'm going to say I want you to run display message, and again I'm going to tell it to pass all command line arguments to the display message function, each argument contained within a pair of double quotes. And that's what that syntax does. That's what double quote $@ double quote says. Pass all command line arguments to the display message variable, the display message function, each argument within a pair of double quotes. And then I'm going to exit with a 0 exit code. Now I don't have to exit with a 0 exit code. I could exit with the exit code from the last executed function or command by using the $? Syntax. So if I wanted to exit from my script using the exit code from display message, I would use that exit command. Here I'm just going to use an exit 0 for the purpose of this video. So now I'm going to exit from this editor, and I'm going to make the temp.sh command executable. We see it's not executable, so we'll do a chmod 755 temp.sh, and now let's run it. And we see that it runs. So let's look at it again. So we see that the temp.sh is simply a shell script that has the definition of my function library. It knows where the functions are by this fpath variable, and then I tell it to run the function display message. So it's going out to this function library, looking for the function display message and running it from there. So my entire shell script now just consists of temp.sh, or consists of an fpath definition defining the fpath variable and executing the display message function from that library. And we can see that my script, the display message script, runs as shown before. So I can say temp.sh -m, here is another test, and so it takes CommandLine Options, does everything that it would do in a standalone script, but now you can do it out of a function library. So before, when you were running it as a standalone script, it was loading everything out of the script, all the functions were being loaded. Here, as running it from a function library, it loads each function once, but it only loads it at the time that it's needed. So that is it on the advanced shell scripting video. And if you would like to see other advanced shell scripting videos, you can go to Mt Xia and look for the training and downloads, and you can download other videos and a variety of other scripts from that website. That is the end of this video. Thank you for listening and watching.